Hello everyone. I'm going to show the general form of continuous compound interest in this video. Let S0 be the initial investment and the compound annual rate of this initial investment be mu. So let us say in the first duration after the first year, the return of the investment is going to be S0 the initial investment plus S0 times the compound annual rate. So if we take the general S0 outside, it will be S0 times 1 plus mu. And let's say if we are going to continue this compound interest for the second year, then the S2, which is going to be the return of the investment at the end of the second year, is going to be S1 times mu plus S1, or in other words S1 plus uh, S1 times mu, which is nothing but S1 times 1 plus mu. And if we substitute the S1 from here, from this previous equation, the S2 is equal to S0 times 1 plus mu the whole square. If we continue this, then the general form of the Sn is going to be S0 times 1 plus mu to the power n. So this is basically the general form of the continuous compound interest if the annual interest is paid at the end of the year. But there are scenarios where the interest is paid more often than the yearly. So let us say that if the interest is paid every 6 months, in that case, S this is going to be the S 0.5 subscript is going to be the return after the 6 months. The rate is going to be for 6 months, which is going to be mu by 2. Then the end of the 6 months, this is going to be the return of the investment. At the end of the year, this is going to be little higher than this S1, because we are going to uh, get an earning for this interest what incurred in the first 6 months. So in that case, the S1 is going to be S0 times 1 plus mu by 2 the whole square. So in this case, now we are getting the 6 months payback for the annual rate mu. And if we generalize this, let us say if we are going to take the monthly return, which means like this is the mu is annual rate, and we are going to get the payback every month. Then at the end of the year, the S1 is going to be um, S0 times 1 plus mu by 12, which is the monthly rate to the power 12. And if you take this for a daily payment, let us say this is the mu is the annual rate, and we are getting the return every day. Then this is going to be the um, uh, uh, return of the investment at the end of the year if the interest rate is paid daily. So let us say we are getting payback every hour, or numerous times, like every second or whatever. Then we can generalize this S1 equal to S0 times um, uh, this is a generalized form, S0 times 1 plus mu by n the whole power n. So let us say if this n is a very large number, which means we are getting large number of payments, a large number of installments of payment in 1 year, then what is the general form of it is the objective of this video. So let's say n tends to infinity, um, um, so then we can apply the limit. So basically we have to find the value of this portion when n tends to infinity. um, so when n tends to infinity, we have to find out the value of this. Um, So here in this case, uh, so we have to find the value of this when n tends to infinity. To find that, I'm just going to make a simple substitution. X is equal to 1 by n, which means instead of n tends to infinity, then it becomes x tends to 0, then 1 plus mu x to the power 1 by x. Um, so um, so I'm going to make another substitution. Like this is very similar to um, uh, a equal to e log a. I mean, that is the general form, not general form, like that is both are same. um, so I'm going to apply that here in the previous equation. So here I'm going to apply that. Then it means the limit x equal to 0, e to the power log 1 plus mu x to the power 1 by x. That again, that can be rewritten as like e uh, to the power limit x tends to 0, then log 1 plus mu x to the power 1 by x. So what I'm going to do is I'm going to differentiate on both sides. Then it becomes so okay, sorry, before that, I mean, this can be rewritten as like log 1 plus mu x divided by x. And now I'm going to differentiate on both sides. Then this becomes 1 plus mu x divided by dx and dx by dx. This becomes 1. And when I do this, it becomes 1 by 1 plus mu x times mu. So then here x tends to 0, which means this terms goes away. Then it becomes a mu, which is um, here, this whole term becomes mu. That means um, so so now so this terms becomes mu. Now that is equal to e to the power mu. So now the S1 has become S0 times E mu. So this is the general form of continuous compound interest. This is the annual rate mu, and this is the initial investment. At the end of the year, at the end of the first installment, the return is going to be S1, which is nothing but S0 e to the power mu, which is the annual rate, which means as mu increases, it is going to have exponential growth. You can see that this is general form of a mu curve. So this is e to the power mu. This is t. Uh, so which means as t increases, this is going to have an exponential growth, which we will see in the next video.